Okay, so thanks everyone for joining. Today I will share some progress on the synchronous Mnesia replication project. In the past sprint, we achieved the following goals. First of all, the feature has been fully merged and integrated to the main MQX branch. We created a user guide for enabling this feature and explaining what it does. And finally, we did a technical feature that fixes the behavior of Mnesia.read function during shard bootstrap. So let's go through these items. So yeah, the feature has been merged. So every Mnesia table that has been created so far has been assigned to a shard, and the shards are now enabled for the respective applications. Everyone is welcome to try this feature out and possibly find bugs and report them. Because, well, I tested it, but my knowledge of MQX is not very deep, so I mostly tested what everything appears to be working, but maybe some subtle bugs could be present. So, yeah. Documentation. We created a user guide that tells how to enable and configure this feature. And this is done in addition to the developer documentation. And finally, to the dirty reads feature. So currently, all the shards have to be bootstrapped when they start initially or they reconnect to the core node. During this process, all the data from the core node is being transferred to the replica. But while this transfer is happening, the replica becomes inconsistent and it cannot be used by applications because they will read potentially, they can potentially read either missing data or some zombie data, whatever. So we used an internal Mnesia feature that allows to redirect all the reads to the remote node. And we basically piggybacked on this feature to enable dirty reads during bootstrap. So how this feature works is that when the shard bootstrap happens, we patch Mnesia schema in a way that disables local reads for the tables in the shard. And these reads are being redirected to the core node that we use as a source of the data. So this way we can be more safe to ensure that the applications don't read any wrong data during accidental reconnect of replica. So yeah, now to the demo. Unfortunately, this feature is a bit tricky to demonstrate, so I will just demo the new test case that I added for this feature. It's tricky to demonstrate because the time window during which the bootstrap happens is pretty small, so yeah, it's we need to do some trickery to get into the correct state. Okay, so how does test case work? We use Snapcafe to artificially inject pods into shard bootstrapping process. So the shard will not enter the normal state for a very long time until we tell it to in the test case. So yeah, this line basically says that the shard should enter a local replay state only after this Snapcafe event has been emitted. So we start the cluster that consists of one core and one replicant node, and we do a dirty write on the core node that inserts some data into the but when we do a dirty write that inserts some data into our test table, then we do an RPC to the replicant node to ensure that the replicant node can read the exact same value which we just wrote to the table at the time when the data is not imported yet. And then finally, sorry about this, finally we allow the shard to start by emitting this event, and then we just continue the test. So basically, by doing so, we test what the RPC to the core node is done when the shard is being bootstrapped. Okay, so I will run this test case. I will run this test case and it will hopefully pass. Yeah, it passes. So yeah, this is the new feature. Now back to the presentation. So what is left to be done for async Mnesia replication? So we need to create shards dynamically. We got a feature request, but tables should be not just static, but could be assigned to the shard in the runtime. Then I think we need to write some blog posts to advertise this feature some more. We need to export shard metrics to Prometheus, so we have more visibility into performance. Potentially enable some replicants in the CI, and of course there will be bug fixes. So that's it for my presentation. Thanks for listening. Yeah. Do you have any questions?
I have one. How many shards do we have in the current state?
Oh, that's a good question. Let me count. Typically, I created one shard per application, more or less. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I think. So yeah.
Okay. When a node starts up, does it have to wait for shards?
No, not really. There is a bunch of shards, but it have to wait because the tables are required for the node to start already. So this behavior is not changed, but we also have plugins that use Mnesia, and these plugins, they are optional, so we cannot wait for shards for these plugins all the time. So we wait for the shards to replicate when the plugin starts.
Okay. And does that mean for future plugins we will have to manually add shards, or where's the dynamic shard creation? What's the use case of it?
That's to assign tables to the shard in the runtime, because currently the way it's done, it's through this annotation in the code. So it's fairly static. You can only so one shard, one table, and this annotation is being read on the startup by ICA. So currently, for example, you cannot just go and create a Mnesia table in like in the middle of give it a name or something.
Do we currently have dynamic table names at all?
This was a feature currently no, but it will be needed, basically.
In which use case specifically? Do you have an example?
Oh yeah, I can find this thread, I hope. Yeah. EMQX gateway table to save client ID registry, and this table should be created and deleted at the runtime. So yeah, basically this thread.
Okay.
Yeah.
And is there a concern about the number of shards we create? What's the like most common or general guidance here? How to use a shard?
Oh well, there is some documentation in ICA about where is it? I believe it is here. So yeah, it mentions how to create a shard, but the reason to create I would say the advice for the case when we can create a shard is if it's a different application that can be started and stopped individually, I think it deserves its own shard. And another is that there are no Mnesia transactions that span across multiple shards. So basically, if you have a transaction that reads or writes certain tables, then all these tables have to be in one shard. So yeah, that's the limitation.
Yeah. Okay, thanks. So a shard is a collection of tables
Yeah.
which are logically grouped.
Yeah, which could be which are logically related, basically.
Okay.
Yes.
So do we have a test case or whatsoever to ensure that one table is not does not belong to multiple shards?
Oh yeah, you can enable a special parameter in ICA. Let me see. So yeah, there is a special environment variable for ICA called strict mode, which basically enables some additional checks in ICA, which will basically crash the transaction when it tries to write any tables which don't belong to the shard. And the idea is that you enable the strict mode in the CI, and basically you passively check that the transactions don't span multiple shards, for example.
Okay. Okay. So it's not just check if a table belongs to no shard at all, but also checks if it belongs to multiple shards.
Oh yeah, this. Oh yeah, I get what you're talking about. This thing is for checking transactions. But in order to check what some Mnesia table belongs to multiple shards, it's done during startup of ICA. It basically will refuse to start if it detects what. Let me check. I think it should be somewhere here. Yeah, so basically ICA will refuse to start if some table belongs to multiple shards. But if a table does not belong to any shards, currently there are no checks for this.
Okay, thanks.
Okay, in this case, thanks everyone for joining. I will stop